The other word problem I want to solve for you here on a video is problem 28 there on page 193. This is our example of a classic motion problem. These problems have been around for centuries, that math students have been confronted with them to try to solve them. So here's what problem 28 says. When a plane flies with the wind, it can travel 4,200 miles in 6 hours. When the plane flies in the opposite direction against the wind, it takes 7 hours to fly the same distance. Find the rate of the plane in still air and the rate of the wind. The rate of the plane in still air means how fast could the plane go if there wasn't any wind helping it or wasn't any wind hindering it. So let's let x be the speed of the plane in still air, and we'll let y be the speed of the wind. And we had two trips, didn't we? We had a trip where we were going with the wind and a trip where we were coming against the wind. Perhaps we could write an equation for each of those trips. That would give us our two equations for our two unknowns so that we have our system that we can solve to answer the question. So let's think about writing an equation for going with the wind and an equation for going against the wind. Well, in both instances, we know the distance of that trip, don't we? Each time, the distance we traveled was 4,200 miles. So we know the distance for each trip is 4,200. And remember that old formula? Distance equals rate multiplied by time. Now, we know the time for each trip. Consulting the book here, when we went with the wind, it took us 6 hours. Against the wind, it took us 7 hours. So the time going with the wind was 6 hours. The time going against the wind was 7 hours. Now we just have to factor in the rate, which rate's just another word for speed, isn't it? Now, when you are flying a plane going with the wind, just like when you're in a boat on a river going with the current, doesn't the current aid your top speed? So if the top speed of the plane is x miles per hour and the speed of the wind is y miles per hour, wouldn't the sum of those two be the speed when you're going with the wind, just like it would be when you're going with the current in a boat? So x plus y, that quantity, would express the rate, the speed, when we're going with the wind. Now, what happens when we turn around and go against the wind? Doesn't the wind fight us, just like a current in a river fights you and slows you down by whatever the speed of the wind is, by whatever speed the current is? So the rate going against the wind, would be the top speed of the plane minus the speed of the wind. And we have our system of equations we can solve. Now, here's something I'm going to look at real quick. Can't I divide both sides of that equation by 6? If I divide this side of the equation by 6, doesn't that give me 700? Dividing 4,200 by 6. If I divide this quantity by 6, won't the 6's cancel, just leaving me x plus y? How about this equation? I can divide both sides of that equation by the 7, can't I? If I divide this right-hand side of the equation by 7, won't those 7's cancel, just leaving me x minus y? And 4,200 divided by 7 is 600. Oh, and look what I have now. I've got a nice system of equations that when I add them, the y's disappear. And I get 700 plus 600, that's 1,300, equals 2x. So x equals 650. And if x is 650, 650 plus 50 would make 700, wouldn't it? And 650 minus 50 would make 600, so that tells me y has to be 50. So x was the speed of the plane. So the plane, without wind helping or hindering, can go 650 miles per hour. And the wind that day was 50 miles per hour. And that's what we might say as far as writing some words to add meaning. We might say speed of plane is 650 miles per hour, speed of the wind was 500 miles per hour. Excuse me, 50 miles per hour. And that's a classic motion problem, especially one revolving around the wind aiding an airplane and hindering an airplane as it travels.